would like to talk today about concrete fundamentals, like the simplest possible discussion of the concrete mix design. And of course, I'm going to concentrate on the need for durability of concrete because I'm talking about Saudi Arabia and use of concrete in this area and in the Gulf in general. We all know that concrete has been used for thousands of years by Romans and others, and their structures in Europe have been surviving up to now. Some of them are doing very well. Why is the concrete mix design and the concrete in construction in the Gulf region and in many countries in the world now are not as good a quality as the historical concrete been used? Well, there is a major reason, which I will mention it now to help you understand what I'm talking about, which is that engineers will build on a site which is usually friendly to concrete. So they will build foundation on the rock, foundation on a mountain, and build the concrete in an area, an environment which is friendly to concrete. Now, with time, everybody likes to build his house or his structure on the coastal area, close to the seawater, because he wants to see the view of the sea and the nice view, or he wants to, or they want to have access to waters and canals and things like this. So actually what happened is that we engineers were forced to start constructing in very bad environments. It's not that the concrete went bad, it's that we went to the bad environment. So as a civil engineer, when I'm asked to build a building in the middle of the sea, I cannot just tell the owner, sorry, I cannot do it. I will tell him I will do it, and then I will start working on that project. As an example, for example, is the bridge that we have between Saudi Arabia and Bahrain, where they came to the designer and asked him, we want the bridge and we want you to guarantee the bridge for 30 or 40 years or 50 years or 100 years or whatever. So the designer became afraid. So the designer want to know what he's getting into. So what he did was he started producing different mixed designs and putting it in the actual water between Saudi Arabia and Bahrain, and look at the durability of the mixed designs that he's used. And actually he found out that the aggregates he's using, if they are local aggregates from the eastern province, they will not survive the duration of this contract period. So he was forced to bring aggregates far away, and actually they brought aggregates from Oman. So you see, the situation is not that we are making worse concrete, we are putting the concrete in a very worst environment. Again, in Saudi Arabia, we have lots of areas which are called sabkhas, where the salt content in the sabkha is maybe 5 to 10 times the salt of the sea and the ocean. So even that is a worst case scenario. So sometimes you have to go through different means to solve the problem. But this is not necessarily true for every structure. It's true for the structures which are subjected to severe environment. As I said, the environment can come to you or you can go to the severe environment. One thing which I found that was very interesting one time, because I'm in concrete, is that somebody told me that tomato paste and tomato sauce is devastating to concrete. As a construction person in civil engineering, I wouldn't think about the effect of tomato on the concrete durability, because we are talking about buildings and houses and offices and hospitals and all this. So in a nutshell, concrete durability, concrete construction is a complex issue, and you really have to know the things that are going to affect your concrete, and then find ways to make concrete that is resistant to those influences. Okay, Now, basically, concrete mix design is very simple. It is made in this area at least because we have plenty of sand plus crushed aggregates plus cement. We mix those three together and we get a mixed design, which is basic concrete, let's say. Then they found out that the laborer doesn't like the mixed design unless you have enough water in it to make it durable, workable, because the heat and the workability of the concrete is affected. So they started to increase the water cement content, and they started using 0.5 to 0.65 water cement ratio, and we were producing concrete which is okay, but it's not a good quality. Then development in the industry came up, and people started using plasticizers, and then super plasticizers, and then even high grade super plasticizers, and then we were able to get the concrete, the water cement and the concrete lower. As we get the water cement of the concrete lower, we got a much stronger and much more durable concrete. Actually, concrete can be made with as low a water cement ratio as 0.25 to 0.3%, 0.25 to 0.3. We can add now super plasticizers and mixed designs to get good quality concrete at 0.4, for example, or a little bit less if possible. So this is the idea of the mixed design and the concrete. So you control workability by controlling the amount of water. You reduce the amount of water. In order to be able to reduce the amount of water, you start to add chemical admixtures such as super plasticizers. Then people started to find out that because the crystal of the cement, which is after the concrete becomes hard, it becomes crystals. The crystals of the cement are not very, very small. They are 3 to 4 micron, let's say. So it is really like a sponge. There is openings inside because the concrete, the cement particle, when it combines with the water, it makes a crystal, and this crystal is not super small. So they started to add admixtures to it, like microsilica or fly ash or silica fuel. If you look at all those, what they are super small particles. That's all what they are. They are very small particles, and hopefully those particles will combine with the mix and fill the holes that are left out by the crystals of the normal cement mixture. So we started adding those products, and we started to feel that we get better concrete with adding, for example, microsilica. Then people said, okay, if we add another item, maybe it's cheaper, fly ash is cheaper, so and so, and we started getting more complicated mixed designs. Then people says, okay, we are worried about energy. We have something called green concrete. What does green concrete mean? Green concrete means I make the cubic meter of concrete with less cement, because cement happens to be bad for the environment. When we produce cement, we put a lot of carbon dioxide in the air. So what they said, okay, let's reduce the cement content to make the concrete labeled as green. Also, they said, let's add other additives like the microsilica, pozzolan, fly ash, which are some of those are all waste material from the industry anyway. Let's add them to the mix so that we save again the cement. So we got this notion of lower water cement ratio, lower cement content, yet we want to still reach the durability and the high performance of the cement. So in a nutshell, this is now the industry starting from making normal concrete before to concrete today. I mean, one more thing that I can just explain here a little bit is that we have more than one cement type. So we have cement type 1, 3, 4, and 5, and so on. Some is called sulfate resistance, some is called shrinkage compensating. Also the cement type came into the picture, but it was not as much important as the other ones. So we have sulfate resistant cement, and we have heat of hydration cement, reduced heat of hydration, but all that has to do with the post mixing, meaning having the cracking in the concrete due to expansion, contraction, and the other things. So you see, the concrete industry is quite complex, and there's lots of points that are around it, and I'll try to cover those points one at a time in future videos. I hope those kind of videos are beneficial to my colleagues, and I think sharing information is a good thing, and since I can do it, I'm happy to be sharing those information. Thank you very much.